Hey, it's Matt here with Mage, and today I've got a pretty fun demo for y'all. We're going to be building an end-to-end pipeline to ingest, transform, and then store data from a weather API, a free historical weather API. And in this demo, I'm going to show you how to pull from a source, run that job using Mage and using a parameterized run, so you can pass in custom variables to your pipeline, change how the execution works, maybe change how it works from day to day, and then UPSERT that data to Postgres. And UPSERT just means update and insert the values. So for instead of having duplicate values, if you define some unique key, an existing row will be updated and new rows will be inserted. So in that way, you can be sure that your pipeline is only pulling in the freshest data and not duplicating any records. But we can jump right into it right here. So I'm going to create a new batch pipeline. Now Mage supports batch streaming, pipelines for templates, and data integration pipelines. If you've heard of Fivetran or Airbyte, that's kind of what a data integration pipeline is. Ours are built on the Singer spec, but I'm going to create a batch pipeline today, and we're actually gonna rename this pipeline. We'll call it weather ETL. ETL stands for extract, transform, load, but most data engineers know that. If you don't, that's kind of the name for our workflows. And I'm going to edit this pipeline here, and we'll start with adding a block, a data loader from an API. We'll call it load weather data. So this is our template data loader in Mage. You can see the main function here, and this operates just like kind of a Python file, everything inside of the main function. So we define our imports, and then typically we'd load data from a URL or an API inside this main function. And then there's a testing function where we can run assertions on our data. But I'm going to grab data from our API. This is called Open-Meteo.com or open-meteo.com. They have a pretty cool weather API. It's free, up to 10,000 daily API calls for non-commercial use. So I'm just in the historical weather interaction. And I think one of the fun things about this API is that if you select the variables that you'd like, it actually generates a nice little Python request for you. Now, there are some packages you have to install here, but I found this usage script here to be pretty much drag and drop. So I'm going to copy that. We're going to paste that inside of our Mage block, and we're going to perform some just pretty simple mutations to what we have here. So first thing is I need to indent this. Second thing is we're going to return this daily data frame. So I don't need this. We can do return. We're going to return pandas data frame. We can drop that as well. Now, if I go through this line by line, we can see that there's things that can be moved or that we don't really need. First, we can take these imports. I'm just going to move these up to the top of the block. Notice that pandas is duplicated. So I'm going to move the imports, and then I see some print statements here. I think that's nice. Now I'll keep we can keep the coordinates. I don't know that we really need the elevation. Actually, we'll drop all of these, and we can build in our own print statements. So Mage actually handles print statements and blocks as logs. So anything that's printed is going to go to your logs in Mage. And the second thing, we don't really need to return multiple responses. For this example, we're only going to return one response. So yeah, we don't need to do that. Just save a few lines here. And then I think it's always important to take a look at exactly what's going on. So we're importing these Open-Meteo libraries that are going to communicate with the API. And then there are some like cache and retry things going on here, it looks. And then we're defining a client that we're going to use to interact with the API. So with this client, with this request, looks like there's an hourly calculation in here as well. And we don't really need the hourly data frame. I think that's a relic from some other things that I selected. We actually just want the daily data frame. So this is a lot simpler now from what we were looking at earlier. Basically, yeah, we're supplying a latitude, a longitude, a start date, end date. Don't need the hourly because we're not requesting that. And then we have our daily request. So I think this is what we're looking at. So now we're going to, this is the kind of the fun part where we supply some variables to make sure that this runs kind of how we'd expect. So the first thing, you note that we have a static start and end date. Well, that's not really what we want, right? as data engineers, we're probably pulling up-to-date or updated data each day. So we'll define an execution date, and we'll set that equal to keyword args.get execution date. So what we're doing here is we're saying, hey, let's look at this keyword arguments dictionary and grab the execution date item. And this is a default variable that Mage passes into every single block, every single pipeline. So when this pipeline runs, there'll always be a date item. And just to convert that to a date is actually a timestamp item, but we're going to convert that to a date by just dropping that there. And then usually when you run pipelines like these, there'll be some lag to the data. For example, this response probably won't have data for today, and it might not even have data for yesterday. So to accommodate that, we can just pull like the last week or last 8 days of data from the API. Depending on what API you're using, like it might not matter. You might just choose to pull an entire year and then overwrite the table. But with changing values, that's usually not such a great idea. So we'll define a start date as well. And the way we're going to define that is we're going to say that the start date is equal to the execution date minus datetime.time delta. And we're going to say days equals, we'll say 8 for now. I believe we have to import datetime as well. So this is just going to give us an 8-day lag for our start date. Now these aren't strings, so we want to convert them to strings when we pass them in. And I think the format for those strings is going to be %year dash %month dash %day. I always mess these formats up, so this could be incorrect. There's a pretty good website out there. Can't recall the name, but it lets you format strings, datetime strings pretty intuitively. So we'll say start string is equal to start date dot strf time. I always forget that one too. Format, and then we'll do the same thing with our execution date. Execution date equals execution date. Execution string equals execution date. Cool. So we should be able to pass these in pretty easily. Sweet. So now we're saying, hey, like let's get our start string, let's get our execution string, we'll pass these in. Now we also have a static latitude and longitude. Well, this really wouldn't be very much fun if we were just getting the same location every time. So I'm going to show you guys how to build in some customizable latitude and longitudes. So we're going to do the same thing we did with the keyword arguments. So we'll say like the latitude is keyword arguments.get lat, and we'll say the same thing for longitude. Now you might be saying, hey Matt, there aren't any variables with those names. Well, we can change that. So we're going to go over here to our pipelines. We'll note this is called weather ETL. Weather ETL, metadata.yaml. And so the metadata.yaml in Mage defines pipeline level variables and settings. So what we can do is we can say variables. So we're defining pipeline level variables now. And we'll say lat. We'll say long. And then we have to come up with fun latitude and longitude. So I'm in the Bay Area. I like going to Santa Cruz on the weekends. Guess what? That's the latitude and longitude I'm going to use. So we'll go Santa Cruz, California. Oh, whoops. Looks like I forgot to save that. So save that just to be sure. And then so latitude is 36, longitude is negative 122. So now we have those defined as variables, and just for fun, we'll also make this a variable. So if you wanted to run this and select more, you could pass in more days than the date range. Save that. Cool, so now we have a pipeline. It's going to fetch 8 days worth of data. It's going to get us a dynamic latitude and longitude. It's going to pass that to the Open-Meteo API. And then it's going to return our values. Let's see if this works. We'll run this. Wow, first try. Let's not often that works. So you can see we have a date. It's formatted as like a Unix timestamp, which is fine. Temperature readings, rain sum, wind speed max, and kind of as I postulated, the last 2 days are blank. So we'll just do like a drop NA here. I'll do thresh. Thresh equals 3, just to be sure we don't accidentally drop a row. So that's saying if a row has 3 NA values, we're not going to return it. So we run that again and drop those 3 values. Cool. So data loaded. And the cool thing, now is like we could run assertions, right? So test output, we're asserting output is not none. Now if we could assert that columns are of a specific type. So we could say assert temperature 2m max dot type is equal to, float or whatever. We could actually, so a good way to test this, well, we'd really test it with a scratch pad. So we'll pass in another block here. We'll do like a transformer. This is kind of what I do to test things sometimes because it's nice to get the keyword arguments from this block. So we'll just run some print statements. Print data dot dtypes. I believe that's cool. So that's what I thought. So I think if we did like a dict, if we cast that to a dict, beautiful. Yeah, so this is where we'd want to assert the data types for the dict, right? So data.dtype. I'm going to assume that we would import the pandas data type. Assert pandas data type equal to. This is most of data engineering, most of building things, looking it up on Stack Overflow. So we'll do, we're going to do it live. Assert all p types is numeric type t call for call in calls to check. Checks out, I think. Watch this. we're doing it. This is the only demo where you're going to see the DevRel guy copy paste from Stack Overflow directly into the output. You gotta love it. We'll comment this out. We'll do this. Cool. So now we have our columns. Not properly formatted, but that's okay. We don't want to check our date. We just want to check the rest of them. And then we're not using T, we're using data. And then we want to do this, not in the transformer block, but we want to do it up here. And we'll call this test dtypes. Oh, sorry, output. One out of one test pass. So you can see we're checking these to make sure they're numeric. It's passing our tests. So now we can be sure that the data that we're pulling from our API is what we expect. If it's not, our pipeline will fail. So there you go. There's loading some data with an assertion. Now we can move on to this transformer and actually transform some of this data. So there are a few things about this payload that I'm not too crazy about. So we're going to make a few adjustments. Actually, the first thing is that we don't have the actual location for the latitude and longitude. And that could be kind of a bummer, right? If you're looking at this data and you don't have that context. So it's kind of difficult to do that in a database. It's difficult to join on a table unless you're pulling in census data. So what we're going to do in this pipeline is just geocode the location, the latitude and longitude to a city and state. So I usually like to use .env for importing my secrets. So I'm going to show you how to do that. We'll import, I think we need requests for this, import requests. we need we need .env from .env import .env values. We need Google Maps. That's what we're going to use as our geo coding service. So the method I usually like to use is I'll have a directory called secrets, and in that secrets directory I keep a bunch of .env files, and that just makes sure that nothing gets committed to Git accidentally because it lives in a ignored directory on my machine. And so what I did is mounted that on this Docker container for this demo. So a nice little way to load that is to do this .env values, and then you can supply the path. You can supply the path of your secrets value, and it's going to open that secrets file, read it in as JSON, and then return the value in config. So the way to initialize a Google Maps client is to import Google Maps and then reference Google Maps.client and then set the key equal to our Google Maps API key, which I defined in that config file. So config.get Google Maps API key. So this is referencing my secrets, pulling it in, and attaching it to this Google Maps client. Now you might be thinking, Matt, this seems unnecessary. Why would I do this? As someone who has accidentally committed API keys to get public GitHub repositories and caused major security vulnerabilities, I would recommend taking all the precaution you can to make sure that it's not possible to accidentally commit a key to a GitHub repo. So you might find that that's useful. So in data, we have our latitude and longitude. Because this pipeline is only pulling in one latitude and longitude, we could do something very simple, which is just say, hey, we're going to geocode this. Gcode. And we're going to pass that to the Google Maps client, gmaps.revert. Oh, I've been saying reverse geocode, but really what we're doing, geocoding is taking an address and converting it to a latitude and longitude. We're doing the opposite, so it's actually reverse geocoding. So this is a little bit of we're getting a little bit of like maps geospatial analysis in this one. It's pretty cool. So the key here, you can pass a list, I believe. If it's not a list, this is going to error out. So we're passing a list with our latitude and our longitude to this reverse geocode argument, and then we're just going to grab the first result because that's really all we care about. And then, so this is from personal experience. I'm just going to copy and paste this one over. This is a dictionary. And so I have this little function I wrote, filter on address component, and it just gets the long name for each item in this address component. I'll show you exactly what that's doing here, actually. I like pprint as well. From pprint, import pprint. If you haven't used preprint before, it's pretty nice for debugging stuff like this. Oh, we got an error. Key. What is it supposed to be? I think we just passed this that way. Sweet. Okay. So you can see we're getting this dictionary back with address components, long name where there's some types, right? Like really what we want is long name where locality in types. So that's what I'm doing here. Get long name for I in dictionary, if component in get types. And the way then that we define this is for the different things that we're doing, we'd say like, okay, well, we want locality. That's going to be filter on address component, locality in G-code. So this is just a way of parsing that dictionary. And I have a few others that we want to grab. So we're going to grab locality, which is like Santa Cruz. And then we'll grab postal code, which is like the postal code in the United States, and state, which is the U.S. state. Postal code is just, for those of you not in the U.S. or not familiar, a numerical identifier for a region that's like slightly different than a U.S. county. I really wouldn't worry about it. And then since we have these, we can set I'm also just going to copy and paste this. We can set those columns in our data frame equal to those values. And then finally, I think it's advisable to rename one column, and that is, so this is actually a pandas command. That is the date column. In some databases, that's a protected name. So we're just going to call that reading date, and we'll do it in place equals true here. And yeah, just avoiding protected names is a good idea. Okay, what's up? Set object is not callable. So that's in our rename. Yep, that's not how you define a dictionary. Cool. So we have our reading date, our temperatures, and then we have our locality, our postal code, and our state. Looking good so far. So we're reading in our data. We're performing some transformations. Now we're going to write it. We're going to write it somewhere. So I'm going to add in a data exporter. We'll just call it, actually, we don't want the base. So I have a Postgres database stood up. So we're going to write to Postgres. And actually, before we write to Postgres, we'll do a little data loader. We'll do a SQL data loader just to make sure it works. I like to do this just to make sure everything's functioning. Like, who knows? Maybe I forgot to turn on the Docker container. So I'm going to use raw SQL, and I'm just going to run a select one. Postgres initialized, we open the connection and return 1. So everything works. We can remove that. Also note, when you delete a block in Mage, it isn't really deleted. You're just removing it from the pipeline. So you'll always have those blocks available in your files. So now we're going to export to our Postgres database with a Python exporter. Write weather data. Forgot where I was for a second there. And the cool thing about this is that there's like very little setup to do. So for a schema, we'll add a Mage schema. For our table, we'll call it weather data. And then, we've already configured our Postgres variables project. That'll be a time for another demo or checking out the Mage docs to learn how to configure that. And so we're going to take our data frame, we're going to export it to our schema and our table. We're not exporting the index. And so now if it exists, we don't want to replace the table. Rather, we want to append the table. And then we're going to add a couple more arguments. And this is what I mentioned earlier, an UPSERT. We're going to do a unique UNIQUE conflict method equals update. So what we're saying here is, hey, we're going to provide you with a primary key or set of primary keys. And if those exist in the database, you're going to update that record. If those don't exist in the database, you're going to add new records. And that's what an UPSERT is, or a merge operation. That's pretty important in data engineering. Usually it's like larger data sets, and this can kind of get slow and you'd run into performance considerations. But for this size data set, I think we'll be pretty good here. Unique. And then the other argument we're going to add is unique constraints. This is where we specify the columns that we want to be unique. So we're going to say reading date, latitude, and longitude, because for any record, those three values should be unique, right? We don't want multiple readings on the same date for the same location. So this should specify our unique values here, right? So we got our reading date. Oh, I don't think we ever added actually the latitude and longitude to our data set. We'll do that up here. Daily lat. Sweet. So now we have, we'll rerun this. Date, we got our lat and our longe. And then we'll add in the locality, the postal code, and the zip. Now you have some more complete locality data. So then when we run this, let's see if this works on the first shot. Sweet. So it looks like this worked. Next step would be to go over to Postgres and take a look. So I have actually DataGrip. It's a pretty good database client. I definitely recommend it. I'll open that up here. We'll see what we get. I was playing around with this earlier. Refresh this. So there might be another database. You can see the drop command comes up. I think we did magic. No, we did Mage weather data. Okay, sweet. All right. Okay, so looks like we have some weather data. We have some null values, so let's figure out what's going on there. That's not supposed to happen. Did I not drop NA properly? Oh, so I specified the threshold here as 3, but that won't work because we added more columns that break the threshold. So if we do 4, right, that would mean 1 column's NA. If we do 5, that would mean 2 columns are NA. So we'll do 5. Perfect. So now actually we'll run this, right? So what should happen here, unique violation, duplicate key value violates unique constraint. And that's because right, we specified what was going on there. And I believe this might have something to do with the null values, perhaps. No, actually, that shouldn't be happening. So if it exists, append if unique. Oh, see, I misspelled conflict here and it didn't throw an error. Unique conflict method. So now it's saying if those exist, we're going to update those values. That's Docker. So if I refresh this table, you can see there aren't any duplicated values here, even though we inserted twice. We didn't overwrite these because we didn't have any. We removed those values from our data set. But now what we can do to test this out actually is we could do like we could just change the range on our pipeline basically, right? So up here we're setting this to 8. Let's change the variables. So I'm going to pull open the variables. We're going to add this. We'll say 100, right? Like let's get 100 days of data. We'll execute this. See, 99 rows and 8 columns. So we'll perform that transformation. Then we'll write this. So we talked a little bit about what UPSERT was. Let's take a look at our database and see what happened. So we still have those null values. We'll sort by date. 5.4. You can see we don't have any duplicated values, and we have readings back into October of 2023. So everything's working as we'd expect, right? We have this pipeline. It's going to pull data from a weather API. We performed some reverse geocoding, added in a latitude, we added in a longitude, and then we took that and we defined an UPSERT operation to Postgres with just a few lines in Mage. And that UPSERT operation is saying, hey, if there are records here that match these unique keys, we're just going to update them. So if you ran this in the future, it would simply write over those rows. But if those records don't exist, we're actually going to insert them into our database. And we just verified that that's working properly. In another video, we'll talk about how to schedule this, how to backfill it, how to play around with those parameters a bit. But for this tutorial, that's kind of it, soup to nuts. So I'm Matt with Mage, and this has been an end-to-end weather API demo pipeline in Mage. Until next time, peace.